Hey guys, so in this lecture we're going to cover the last part in chapter 24 and the second part from the lecture today we're going to start in chapter 25. So the starting point will be the right hand rules. Just a quick reminder for the right hand rules when we use our three fingers to identify the direction or the relation between the velocity and the magnetic field and the magnetic force. And the new thing here is today the right rules hand, it's applicable for a positive charge. Now, in this example here, what the situations or how we apply the right hand if we have negative charge as we see here. And the rule is very basic here. If you see the figure number 1 here and see the direction of the velocity in these directions and the direction of the magnetic field pointed up using the right hand rules, you will find your magnetic field or the magnetic field force point toward the page, out of the page. But this is when if I have positive. But if I have negative, the only difference here just flip the velocity directions, which mean in this case here will be the magnetic field point toward the page, not out of the page. So the only thing you change the direction of magnetic field force if we have negative force. So let's apply for the second part here. When we have the negative charge, with this direction go to the right, and they have magnetic field point out of the page. So if you want to apply the right hand, you will see the magnetic field or the magnetic field force will be point down if you use the magnetic field or the right hand rules. But since this electrons, magnetic field, it should be pointed up just because if it is a negative charge, not a positive charge. So right now the magnetic field will be point up, not point down as the right hand rules pointed to. Just a clarification between positive and negative charge. Now, once we are done to identify the directions of the force, now how to find the magnitude of that force. With the magnitude of that force here's the summary for what we have 3 point A and B, and here is the formula that we use to identify the magnetic field force. It's dependent about the charge, with absolute value, it doesn't matter it's positive or charge or negative, and velocity and magnetic field. And the new part here for us here is the sign alpha. What is alpha is alpha, it is the angle between velocity and magnetic field. That's the alpha definitions. Okay. So let's apply now this concept here for this numerical example and see how we can find magnetic field as a magnitude and as the directions. We're going to use the right hand rules, but there as a magnitude, we're going to use our formula to find the numerical value or the magnitude. So here's I have a magnetic field point up, velocity point to the right. If you use the right hand rules, you will find the magnetic field force point out of the page. Now, what the magnitude is? The magnitude for the force, we're gonna use Q multiply by velocity multiply by P. Where is the P? The magnetic field, and times sine alpha. Where is the alpha? Is the angle between what the angle right now between velocity and magnetic field. So here is the angle right now. Here is the alpha, which in this case equal 90 degree. So 90 degree. So now I just plug my numbers. Q, it will be have protons, so it will be 1.6 power to the minus 19 coulomb. This times velocity. I have velocity, it is 4.3 times to the power 5 meter per second. And the last part is regarding for the magnetic field will be 115 Tesla times sine 90 degree. So 90 degree sine, this one is 1. So basically just plug those number here. So just make sure this one's the equal 1. So if you plug those number here, you will end up with the magnetic field force power to the minus 14. We call it a force. So this one the unit as a Newton. And where is the directions? It is out of the page. It's just the first example here. Let's see the second example right now. So first one, we have the magnetic field is point toward the page, and we have the velocity point to the right side. We're gonna use the right hand to find the direction of magnetic field, and then we find what the alpha in that case is the same thing is alpha. It's still alpha between velocity and magnetic field. That's the only thing is magnetic field point that way. So the direction here is the alpha, still the same thing, equal 90 degrees. So there is no change with the my angle. So regarding for magnitude, let's apply the right hand rules. You will find your force pointed up as a magnitude. We're gonna write down our formula. Here is the absolute value of Q times velocity times magnetic field and times sine alpha. So we have a charge here is 20 nano power to the minus 9 coulomb times velocity 10 meter per second and times magnetic field 6.5 power to the minus 4 Tesla. And if you calculate this number here, you will end up with the 1.3 power to the minus 10 Newton. But regarding for the directions, it's pointed up. Pointed up. Okay. So this is the second example. Let's move to the new example here. When we have the alpha, it is not equal 90, or is not, they are perpendiculars. If you remember, guys, when you're talking about the right hand rules, when we have the velocity with certain angle, we mentioned about we have two components. The vertical component will be 0. There is no force. And the only component that we have right now it is horizontal one. But I don't have, oh, sine or cosine. I don't want to focus about this one. You are focusing about something. It is force equal Q times velocity times B, and this one should be sine alpha. The only thing you have to identify where is the alpha is. The alpha, it is mentioned, is the angle between velocity and magnetic field. So right now, the angle between velocity, this is my velocity, and this is direction of magnetic field. So my alpha, this is angle here. This is my alpha, which in this case here is just 90 minus 25. So this one should be 65. So it's nothing regarding, oh, it's sine or cosine. It's still sine, but the only thing I need to identify the directions and apply my formula. Now I have all the information that I need. Q is 15 nano power to the minus 9. This coulomb times 10 meter per second. Meter per second, and times 6.2 power to the minus 5. That's sine 65 as the angle. So now you calculate this magnitude here. You will find 8.4 power to the minus 12 Newton. For the directions is, that's the direction we're talking about. It should be in the right side. Going to the right. Now the last part, this example here, we're looking to find the alpha, which is the alpha, the angle between velocity and magnetic field. So we have here is the alpha equals 0, my force formula is Q times V times P sine alpha. Since we have alpha equals 0, so the sine alpha equals 0. So this is 0 value. So in this case, I end up with the 0 in Newton. I have no force when I have 0 angle between magnetic field and velocity of my charge. So last part in this video here, we have here is the 4 charges, and they ask you to rank the magnitude of magnetic field or the magnetic force from the largest to the smallest. So we're talking about the magnitude. We're not talking about the direction. So the directions, you can use your right hand to find out. But we are looking for the magnitude only. So the formula that I will use, this one is the force. It is magnitude value of Q times V times P and sine alpha. This is my formula I will use in that case. So let's see. Let's find the force A. Force A, it will be what half I have Q, it is a Q times velocity is 2V times magnetic field, it is B times sine alpha. Right now it's sine 90 degree. So in this one here, it will be 2Q VP. Let's call it this one 2F. 2F. Just make sure it's the F equal Q times V times B. So this is the first one. Let's go for the first, the P. In that case, I have a Q times V times B. So sine 90. And this one will be F. Let's find the third part, on the C. Q, in this case, I have 2Q times 2V times B. I end up with the 4QV times B, which would be 4F in that case. So it's 4F. 4F. The last part, the force in the last part, 4D. Here's the thing, guys. We have the alpha here equal 60. So don't forget the alpha. What about the Q? I have 2Q. What about the velocity? I have 2V. Magnetic field will be B. And this one here will be sine 60. Sine 60. You will end up with the 3.5 from the F. So right now I can say the maximum value here, I have force for the D. The second one comes force of the C. The third one comes force of the A. The last one, or the smallest one, will be force in the B charge. Okay. I'm done with the recording of this video, and thank you. I'll see you next video.